Hi everyone, I hope you are doing well. So in today's video, I'm actually going to walk through the VCE 2023 sample paper for the maths methods. So yeah, I've had a lot of students, begging me in my tutoring classes to walk through this paper. And yeah, so that's what I'm going to do today. So let's get ready. Okay, let's start with question 1. Let f, so f is our function. Okay, straight away this is our domain. We can see that it's a restricted domain. Here's our function, f of x is, okay, so we can see that it's a rectangular hyperbola. Let's just learn what an actual rectangular hyperbola is. Let's learn the features. So, what we know about a rectangular hyperbola. So, in the form a over x plus b plus c. So, let's say this is our rectangular hyperbola. It's normally in this form. We have two asymptotes. We have an x asymptote and a y asymptote. Our y asymptote, which is our horizontal asymptote, is always this value over here. It is your c value. It's that value over there. For example, if we look over here, what's our value? It's this 1 over here. So we know that we have an asymptote at y equals 1. Now, we also have another asymptote, and we call that a vertical asymptote. And it is to get that asymptote, we look at the denominator and we solve it by letting it equal to 0. For example, x plus b equals 0, where x is equal to negative b. This is another asymptote, x equals negative b. But for this certainly question, we know that x plus 2 equals 0 is x negative 2. This is our x asymptote. Yep. So I'm just going to rub it over here and write it nicely here. X negative 2. Perfectly. All right. These are the features of what we can take out of a rectangular hyperbola. So what can we also know? Can we predict how the graph looks? Absolutely. So a rectangular hyperbola, because we have a positive dilation here, it would normally look like this. That's what it would look like. So let's try to put everything together. First, I'm going to actually put the asymptotes. So y equals 1. So let me just do that. So y equals 1. So at y equals 1, that's an asymptote, and x equals negative 2 is our next asymptote. Yep. Before even reading, on the axis below, sketch the graph, label any asymptotes, which we've done that. Perfect. With the equations and endpoints and axial intercepts. Okay, let's try to find the x and y intercept. First, let's find the y-intercept. So for your y-intercept, let f10, 0, which is 1 plus half, which is 3 over 2, which is over here. Let's try to find our x-intercept. For our x-intercept, we solve f of x for 0. That will be 0, 1 plus 1 over x plus 2, negative 1, x plus 2, negative 1, x plus 2, negative 1 minus 2. Therefore, x is actually equal to negative 3. This is our x-intercept over here. Perfect. And now, because we know how the graph will look like from this, we can just start to sketch it like this. So it would go like this. It will approach all asymptotes, but never touch them. Something like this. Perfectly. And let's label the axial intercepts here. So this would be 0, 3 over 2. This one over here would be negative 3, 0. Okay. Let me just draw this nicely. Perfect. I just put this over here. Okay, perfect. Before we actually have finished the question, we need to remember we have a restriction, a domain restriction from negative 3 to negative 2. So what that means is that we have to delete this over here. So it's from negative 3 to 2, which is our asymptote, and negative 2 to infinity. So yeah, this is how the graph would look like. Have we forgotten anything? does not, we don't, okay, nothing, doesn't look like we've forgot anything. So yeah, that's the graph. We've labeled all asymptotes, endpoints, and axial intercept of the coordinates. Perfect. Question B. Find the values of x for which f of x is less than 2. Okay, to do that question, the easiest way is to use your graph. So I'm just going to take a picture of this graph over here. It's a screenshot. And I'm going to use it to help me answer that question. Okay. So let's go down here and paste it right over here. Let's look at it. So what we want to have, so remember, f of x is our blue graph. And what I like to do is that 2, I like to make it an equation like y equals 2. So y equals 2 is right over here. So I'm going to draw that and write y equals 2. So what we want to do is think about it like this. F of x must be less than or equal to 2. So we want f of x to be less than 2. So where in the graph is f of x less than 2? So when it's in the graph, is the blue graph less than the pink graph? Let's look for those. Well, what can we see? Okay, from -3 to -2, it's less. Good. We can see at this point of intersection to this goes to infinity, it is low still, so that's good, but not at this point here because it goes above. So yes. So what I'm going to do is I'm going to try to find that point of intersection first. So to find that point of intersection, I'm going to let f of x equal 2. I'm going to let it equal 2. And I'm going to solve now. So what's the equation? 1 plus 1 x plus 2 equals 2. 1 x plus 2, 1 x plus 2, and 1 minus 2 equals x. Therefore, your x value is -1. Okay, so this value here is -1. That's actually very useful now that we know that. So this coordinate is -1 to 2. Okay, so let's write what values is it less, if f of x less than 2. So we would write x is an element from -3 inclusive to -2, not inclusive due to the asymptote. And we can straight away see we also have to say from -1 to infinity. Perfect. See, -1 to infinity. That's, yep, perfect. Hope that's right. So I'm just going to take that and push it over there. I'm just going to highlight that color over here. That's your answer. Hope that's right. Let's look at question 2. So question 2 says, consider the function f and g. So we know f has a domain of all reals and it's a parabola. And g is a square root graph. State the range of f. Okay, what I'm going to do straight away is I'm going to sketch f. So I'm going to sketch f. Okay, so it's translated -9 units down. So this is how the graph would look like. And this is -9. So I can straight away say that the range of f is -9 included to infinity. Very easy question. 1 mark. Determine the rule of the equation and state the domain of the function this. So this notation just means f g of x. So it's a composite function. So to state the rule, it's very easy. So f of g, what's the function f? So for x squared, we're going to shove root x for the x's. So it'll be root x squared minus 9, which is x minus 9. That is your equation. Now let's try to find the domain. So for any composite function that exists, the domain of f of g is actually equal to the domain of the inner function, which in this case, if you look, it is g of x. So it's the same as g. Now, what's the domain of g? Well, it's right over here. 0 to infinity. Therefore, your domain of f of g is actually 0 to infinity. Easy 2 marks. I'm just going to highlight those answers over here. All right. Next question. It says, let h be a function. Okay, so they haven't given us the domain, and it's, again, the same parabola. Determine the maximal domain such that g of h exists. Okay, so we want g, h of x, to exist. All right. For a composite function to exist, it must meet this condition. So it must meet this condition. This condition is that the range of the inner function, which is in this case h of x, must be a subset of the domain of the outer function, which is g of x in this case, which is g. So what's the range of h in this case? So the range of h is -9 to infinity. And the domain of g, which was 0 to infinity. Is -9 to infinity a subset to 0 to infinity? Absolutely not. And here we can see if we draw a nice timeline. Let's draw a nice timeline here. Let's say it's -9 and this is 0. Let's say this purple color is for this. So -9 to infinity. So it's inclusive -9 to infinity. It goes like this over here, like that. Let's say this green color goes for this over here, which is 0 inclusive to infinity. We're saying that the purple graph, does the purple graph go into the green domain, like the green domain? Absolutely no. We can see that the purple graph, that the purple line is actually bigger than the green line. So we want to kind of restrict it to make it fit into it. So to do that, let's just draw h of x. So let me just draw h of x over here. Let's draw h of x over here. Okay, let's just draw a nice h of x here. H of x is this parabola over here, like that. Nice parabola. Okay, which is -9. That's 3. That's -3. Okay, we want to restrict that range of h to fit that domain of g. We want to restrict it to here. Like, we want to cut this part over here. So what we want to do is we want to change that range for 0 to infinity, actually. We want to change that range. So let's look at this h of x function over here, and let's change that range. If we want it 0 to infinity, it means that we must delete this part over here. This part's over here. These have to be deleted. Because, yeah, there we go. It means this is how our graph would look like. And now, what's our domain of this graph? What's the domain? That's what we want. The domain of this would give us the domain, the maximal domain of g of h. So that would say, okay, then let's write it. The domain dom of g, oh sorry, for this case it's g of h is actually, I'll write it down here, -infinity to -3 inclusive union 3 to infinity. That'll be your answer. So let me just highlight it, and I hope that's right. Just this one over here. It's not nice, so let me just here. Perfect. Now let's get to question 3. Find the general solution of 2 sine x equals tan of x for all x is an element of all reals. Okay, so let's solve for this. What we know is that tan of x is actually equal to sine of x over cos of x. So let's sub that in. So 2 sine of x is equal to sine x over cos x. Let's multiply both sides by cos x to get rid of that division of cos of x. So that'll be 2 sine of x cos of x equals sine of x. All right. Now, a lot of students, this is where they make the mistake. They divide the sine of x to get rid of it. They think that they can divide it. Now, yes, you can divide it, but the problem is you will miss out a solution. You will be missing out on a solution. So don't do that. That's the biggest mistake that students do. And this is what you should do. What you want to do is you want to bring that sign over here. So we're going to say that 2 sine of x cos of x minus sine of x equals 0. Factor sine of x out. And now we can solve them. So sine of x equals 0 and also cos of x equals half. So here we have two nice solutions. They're not solutions, but yeah, we're going to solve solutions for these. So let's do the first case, which is sine of x. Let's look at sine of x. Sine of x equals 0. This is how I like to do general equations, is by looking at their graphs. So I'm just going to draw a nice graph over here of sine of x. Okay. So sine of x goes like this. Goes like this, up, down, like that. And we know that this point here is 0. This one's pi, this one's 2 pi, this one's 3 pi, and this one's 4 pi. So when does it equal on 0? Well, it equals 0 at this point. Well, it equals 0 at this point, at this point, at this point, at this point, and at this point. What do we know the difference is? That they all go through pi. For example, this 0 plus pi goes to this pi. Pi plus 2 pi goes to this. Like, in any way, it is the addition of pi. So it's like a factorial of pi. So what does that mean? Well, we can write a general solution like this. For this example, we're going to say that x will equal pi n, where n is an element of all integers. What does that mean? Is that true? Yeah, absolutely. Let's say we put n equals 0, which is 0 in this case. Let's say we let n equals 1, pi, 2 pi, 3 pi. So it actually works, and we can even do the negatives, like negative pi. Yeah, so that is the general solution for that equation. Now, let's look at the second case, which is cos of x equals half. So for cos of x, I'm going to actually do the unit circle. So I'm going to draw a unit circle. Let's draw a big unit circle over here. Okay. All right. Just going to draw a unit circle. Okay, just come on. Oh, it's not working. All right, like that. It's not the best, but it does the job. Okay, let's look at this unit circle. There's an acronym. It's called CAST. C-A-S-T. If I'm not mistaken, CAST. Yeah, so it's like that. So CAST tells you so CAST means C actually means cos. A means all, so cos, sine, tan. S means sine, T means tan. It tells you that cos on this part is positive. These part is in this quadrant, it's all of them are positive, and sine would be positive at this side and tan would be at this quadrant over here. Because we know that from this graph over here that cos is a positive number, because half is positive. It's not negative half, it's positive half. We know that we're going to look at these sides, these two, because cos is positive in here, and A means all of them are positive over here. So let's look over here. I like to draw a nice line here and here, because they're both positive at those sides. what is the actual base angle in this equation? It is pi over 3. So, what I'm going to do is I know over here, this would be pi on 3. And this here would be negative pi on 3. So that means as we rotate, think about it like this. If we rotate this graph, full rotation, we have the plus pi over 3 to make to a solution. Also, we have the minus pi over 3 to make another solution. So think of it like that. So there is actually two general solutions for the equation. The first is x equals 2 pi n. Again, why? Think about it like this. A 2 pi n is a rotation, a full circle rotation, plus pi on 3, where n is an element of all integers. Also another one, x equals 2 pi n minus pi on 3, where n is also a number of all integers. These would be your two solutions. I'm just going to highlight those right over here. Perfect. I hope those are right. Let's go down for the next equation. So here it says, consider the simultaneous equations below where a and b are real constant. All right, find the values of a and b for which the simultaneous equations have no solution. Okay, so we know they are linear lines, so they're straight lines. For a straight lines to have no solutions, what do we know? What are the conditions? Let's just have two graphs. So this is a straight line. Let's say this is a straight line, and this is m1. This is its gradient. And it also has y1. It has a y-intercept at some point. Let's draw another graph and say, let's say this is your second line. And this one has m2 and y2. So that's your gradient and that's your y-intercept. So the only condition for there to be no solution is that they must be parallel. So can you see those lines are parallel? And they never actually intersect. So they are parallel and they'll never touch each other, meaning that there will be no solution. So this is what we must meet. So what? What are the conditions? The conditions are that the gradients here must actually equal to each other. But the y-intercepts do not actually equal each other. These are the conditions that must be met. So let's just try this out. Okay, what I'm going to do is to find the values of a. A quick method is to actually use matrices. So I'm going to just draw a nice matrices box here. And I'm going to put this over here first. A plus 3. What's next? A 9. I'm going to close that. There's a 2 here, so I'm going to put it down here. And there's a here. I'm going to put that a here. So for matrices, we're going to use a determinant. So to actually calculate those values. So the first step is to multiply these two together. So that will be a plus 3. And we're going to put a minus here. Don't forget that minus. And these together, now we multiply these together, which is 9 times 2, which is 18. 18 equals 0. Now we solve for a. A squared plus 3a minus 18. A 6, 3 minus, so that'll be a negative 6 and a 3. So we have two values of a. So what we need to do now is to check if those conditions, let's try to check that if these conditions are going to be met for these values. They could be both values of a could be right, one could be wrong, or both could be wrong. So we need to double check them. So let's do that over here. Let's do that over here. Nicely. Okay. First case that we're going to do is case 1. A equals negative 6. All right, let's do that. So for a equals negative 6, we're going to sub it to these equations over here. We're going to sub it into these two equations over here. So let's do that. So let's sub into the first one. So this is 1, this is 2. Let's sub into the first one first. We're saying that negative 6 plus 3x plus 9y equals 3b. That'll be negative 3x plus 9y equals 3b. That means 9y equals 3b plus 3x. Y equals b plus 3 over 3, which is actually equal to b on 3. I forgot that x over here. Wait. What have I done here? So plus b. Okay, I just made a small mistake over here. Let me just rub that out. Okay. Plus b plus x over 3. Okay, which is actually equal to b over 3 plus x over 3. Okay, perfect. So we know that the y-intercept here. So for this one, we know, let's call it m1. m1, so the gradient is 1 on 3. And the y-intercept, so y1, equals b over 3. Okay. Now let's sub it to the second equation now. So for the second equation, I'm going to do a different color. So we're saying that 2x minus 6y equals 5. That'll be 6y, 2x minus 5. Y, 2x minus 5 over 6. Y, x over 3 minus 5 over 6. Therefore, your m2 here, let's call it m2, is 1, 3. And your y2 is negative 5 over 6. Okay. Are the gradients the same? Yes. We can see that the gradients are the same. Perfect. Are the y-intercepts different? They must be different. Well, this is negative 5 over 6 and this is b over 3. So what values of b do not equal to negative? So we want to make sure that b over 3 must never actually be equal to negative 5 over 6 for it to be no solution. So what I'm going to do here, I'm going to write it like this. I'm going to equate them. So b over 3 must not equal negative 5 over 6. Therefore, b must not equal negative 5 over 2. So, for this one, perfectly. So, that will be, we can rewrite this as b is an element of all reals with the exception of negative 5 over 2. So, that is, for that one, that's actually a solution. So, I'm going to write that solution over here, just over here. So, the first solution is a equals negative 6 and b is an element of all reals with the exception of negative 5 over 2. Okay, that's one. So we got an actual solution. Let's try now a equals 3. That's the other case we have to make sure to double check. All right. So this is where the case where a is actually equal to 3. So that will be 6x for the first equation plus 9y equals 3b. 9y equals 3b minus 6x. Y equals 3b minus 6x over 9. So that'll be b on 3 here. And here will be minus 2x over 3. If I'm not mistaken. Is that true? I think so. Yep. So let's say this is m1. So m1 equals negative 2 on 3. And your b1, your y1, so your y-intercept would be b over 3. Perfect. Now let's put it in the other equation, which is 2x plus 3y equals 5. 3y, 5 minus 2x, y, 5 minus 2x over 3. Therefore, this can be written as 5 on 3 minus 2x over 5. Therefore, your M2 here is negative 2 over 5. Oh, sorry. Oh my god, what am I doing? Okay, here I made a mistake. Why am I writing 5 here? Must be 3. Okay. Okay, nothing. Okay, perfect. And then y2 equals 5 over 3. Okay. So, are the gradients the same? For this one, yes. And for this one, yes, absolutely. And are the y-intercepts different? So here's b over 3 and this is 5 over 3. So let's equate them the same as we did for the other ones. We want to say that b over 3 must not equal 5 over 3. Which b must not equal 5. So we can rewrite this as b is an element of all reals with the exception of 5. And that's another solution. So let me just do that for this one. Another solution is when a is equal to 3 and b is an element of all reals with the exception of 5. Okay, these are your two solutions. Damn, that's a long question. Very long question. How many marks is this? Okay, 4 marks. Makes sense. Yeah. Okay, that's all right. I hope that's right. Okay, let's go to question 5. So for question 5, it says, let f, okay, this is your function, all reals. That's your domain, where f of x is this. It is a parabola. Calculate the average rate of change of f between -1 and, okay, so this is not bad. So to calculate the average rate, so it's f on 1 minus f on -1 over, just over 1 minus -1 equals. So when we stop in 1, that will equal 1. And also when we stop in -1, that's 1 over 2. So that will equal 0. Okay, that's your solution for this one. Perfect. Calculate the average value of f between -1 and x equals. Okay, to calculate the average value, it's 1 over 1 minus -1. The integral from -1 to 1 of the function, so if the function is 2 minus x squared with the respect of dx. This equals 1 plus 1 half. Okay, so that'll be 2x over here minus x, 3 over 3, 1, -1. Okay, so let's simplify that more. If we put a half over here, so let's sub 1 in first, so that'll be 2 minus 1 on 3 minus, now sub in that -1, so that'll be -2 here, and we can say +1 on 3 here. Okay, let's continue over here, so that'll be half, so 5 on 3 minus, here would be what's -6 plus 1, so that's -5 over 3, which is equal to half 10 over 3, which is equal to 5 over 3. Okay, that is your average value. To the next question. All right, 4 trapeziums of equal width are used to approximate the area between the functions f of x and the x-axis from x -1 to x equals 1. The heights of the left and right edges of each trapezium are the values of y equals f of x as shown on the graph. Find the total area of the 4 trapeziums. Not bad. Okay, so when you look at this graph, you can already see that there is symmetry, which is so useful if you look at it. So how? So let's just draw this line over here in the middle. If we can find the area of these 2 trapeziums over here, we can double them and get the area of these trapeziums, or like the overall total. So that's what I'm focusing on right over here. Let me tell you. So I'm going to do these 2 trapeziums, these positive 2 trapeziums over here. All right. Okay. Okay. All right. Okay, this is the rule. Area is equal to What is the width of each trapezium? Well, we can see it's half. So we're going to put half. Bracket. What is the initial? So what's the initial value that we're starting from? That's 0. This one's half, and that's 1 over here. So the first value is 0. So we're going to say F0 plus, what's your second one, which is half? So we're going to say 2F half. And why do we write that 2? It's because it's in the middle. Yeah? It's so what we start off and what we finish off is we write them by just F on 0 and F on 1. We don't actually double them. We don't double them like the middle value, which we've done here, which we've put a 2 in front of it. Yep. So we need to understand that. Perfect. So it means that the next value here would be F on 1. Bracket. Now, we don't want to forget there's an extra half that we must always put, and that half actually comes from the area of a trapezium. So the normal area of a trapezium is half. I think it was A plus B, C. That half we cannot forget. So that's why we put a half over here. All right. And this, let's simplify. So what's F on 0? We can see that F on 0 is 2, so we can put a 2 here. Plus 2, what's F of half? F of half is, we know the equations over here. So we can say that 2, so F of half equals half squared. So we're saying that 2 minus a quarter, which is 7 over 2. So we can say 7 on 2. Plus, what's 1? So we'll put 1 here. So 2 minus 1, that's 1. So perfect, 1. Don't forget that half over here. So your area is half. What's 2 plus 1? So that's 3 plus... Wait, am I mistaken here? Oh, so, okay, here I've made a mistake. Why did I write a 2 here? It's supposed to be a 4. It's supposed to be a 4 here. Okay, so 2 plus 1 is 3. Plus 7 over 2, bracket half. Area is a quarter now. Okay, so 13 over 2. So area is equal to 13 over 8. Okay, so 13 over 8. So that's the area of the two trapeziums here. Now we're going to have to double them. So your area, your total area, is actually equal to 2 times your 13 over 8. Which is 13 over 4. Units squared. Okay, this is your final answer. So I'm just going to highlight it over here. Hope that's right. Okay, next question. So, Newton's method is used to estimate the x-intercept of a function f of x. Verify that when f is -1 is greater than 0, and when f is -2 is less than 0. Okay, let's verify the first part here. 1 and 2. So we want to first verify. I'm going to use a different color. But if we want f -1, let's verify that. So when something says f -1 is greater than 0, we're saying that it's positive because it's greater than 0. So let's sub in f -1 here first. So that'll be -1 on 3 minus 2 plus 4 equals 2 minus 1 on 3, which is actually 5 over 3, which is positive. It's an actual positive value. So we can say that 5 over 3 is actually greater than 0, and it's true. So that is a way we can show that we've verified it. Now let's try the second part. So we're saying that's negative. So f -2, which is 1/3 -8 -4 plus 4 equals -8 over 3. So we can see it's a negative number now. So we know that -8 over 3 is less than 0. So we've also verified that. I hope that should give you the mark. Now, using an initial estimate, x naught equals -1, find the value of x. Okay, so now we're using Newton's method to solve this one. So you should know the formula. So the formula is x1 must equal x naught minus f x naught over your derivative of f x naught. So let's try to do that. What is our x naught here in this value? So it's -1. Let's try to sub that to f of x. So it would be f -1, which is over here, which is this value over here. So 5/8. Okay, that's perfect. Now we want to find the derivative to calculate for this one over here. So let's first calculate the derivative. So f dash of x is actually equal to, bring that 3 over there, so that'll be x squared plus 2. So in f, we sub in -1. That'll be 1 plus 2, which is 3. Now let's come back here and let's sub everything back together. So we're saying that x1 is equal to -1 minus, bracket, 5/8 divided by 3. Okay, so x1 equals -1 minus, okay, 5/8 divided by 3 would equal, I just want to double check the difference, right? So 5/8 divided by 3, okay, 5/24. If I'm not mistaken, isn't it? Wait, have I done anything wrong here? So x0, okay, that'll be 5/8. Okay, no. Oh my god, that's why I'm not so unsure. Okay. Here is a problem. It's 5/3. Okay, this is, I'm just going to change that here. 5/3. Okay, so that's why I'm just confused. I'm like, what's this question? All right, it's not making sense. Okay, so 5/3 over 3, which is s1 -1 minus 5. So 5/3 divided by which is 5/9, which is what's -9 minus 5? That will be -14/9. Okay, perfect. So your value of x1 is -14/9. Just want to double check, if that's right. So, God, yeah, I'm just quite confused. So is that right? If I put it over here, it's method to estimate. Okay, I think it's right from what I'm looking. Okay, perfect. Yep, I hope it's all right. All right. Okay, is this the last question? Okay, yes, it's the last question. Perfect. The duration of a telemarketing calls to a mobile phone user is a continuous random variable t minutes with a probability density function. Okay, we've got this function, find the value of k, such that 90% of the telemarketing calls last less than k. Express your answer in this form, where a and b are positive integers. Okay, so find the value of k, that 90% of the telemarketing calls, so last less than k. So we want to find the actual probability that t is less than k will equal 0.9. That's what we're trying to actually find. So this can be rewritten as, in a probability density function, 0 to k of the function. So I'm going to bring that 2/5 over here first. e -2/5 t dt equals, so 0.9 is just the same as 9/10. Always write in fractions, it's much easier to deal with. And okay, so 2/5, okay, that'll be -5/2 e -2/5 t k0 equals 9/10. Okay, these cancel out. We're saying that -2/5 t k0 9 over 10. Okay. Alright, so nearly done with this. Okay, so that will be negative e, negative 2 over 5, k, minus negative e, 0, 9 over 10. And that's negative e, negative 2 over 5, k, plus 1, 9 over 10. That's e, negative 2 over 5k, 1 minus 9 over 10. Negative 2 over 5k, 1 over 10. Have I made a mistake here? So, okay. Yep, perfect. That'll be log e, 1 over 10, 2 over 5k, and that'll be negative 5 over 2 log e 1 over 10 equals k. Is that right? Did we get in the form? A and B are positive integers. Okay, we've got a negative here, so okay, we can simplify it by 5 over 2 log e 10 equals k. Okay, same as that. Okay, is that right? So A and B are positive integers, 5 is a positive, B is also positive, and C is a positive. Yes, I think that's right. I hope it is right. Okay, that'll be it, guys. Okay, I hope you guys enjoyed this video. If you haven't yet, please comment down below if I've made a mistake, because I'm not too sure. Maybe the algebra, I've made an algebraic mistake or something. Yeah, please comment it down below. I hope you guys enjoyed this video, and please make sure to like and subscribe to this channel. I do tutor online. I have a Discord server, so if you guys want help with anything, one-to-one session, please go check out my link in the description. You will find my email, which you can email me, and we can have a discussion if you want a one-to-one tutoring. I do tutor the subject specialist maths, VCE, mathematical methods, physics, and chemistry. So yeah, I'll be doing some exams like this in the future. So yeah, I hope you guys enjoyed this video, and please make sure to like and subscribe. Have a good day. Bye bye.